So, in this session, we're going to be discussing cryptocurrencies and all topics related to them, the various types of cryptocurrencies, how they basically work, what forking of a cryptocurrency generally is, and the underlying technologies. So, Sam, over to you.
Yeah, so maybe we should start off and briefly mention, talk about digital cash or electronic money. These concepts that came before cryptocurrencies and before Bitcoin. So, I mean, people have been doing digital payments like over the internet and even before the internet for quite some time. So those like digital payments, and I mean, you've always probably used PayPal, and if you use the banking system at all, they've been doing digital payments for a long time. So cryptocurrencies is a new thing that was primarily came onto the scene with Bitcoin, but it's something that folks within this cypherpunk movement, these are sort of cryptographers that are hobbyists and enthusiasts and researchers, have been trying to come up with a new type of digital payment where it has these it's built on cryptography, specifically public key cryptography, which we'll talk a little bit more later, and is decentralized, meaning unlike the existing digital cash or e-money or PayPal, let's say, you can create a transaction that is somewhat anonymous and send funds to someone else that's also anonymous, and nobody can stop you from doing that. And there's some challenges in doing that, but the basic concepts were how can we use public key cryptography to achieve this? And so real quick, since all cryptocurrencies are built on public key cryptography, I'll just give a quick overview of the basics there. So the idea is, so normally with before public key cryptography, if you were encrypting something, you would have a secret. So you have some document or some file or a bunch of text, and you want to hide it and then transmit it to someone else. And so let's say I'm sending a message to Hossein. So before public key cryptography, Hossein and I would meet up in person. We would have some secret, what they call a secret key. It's a shared secret, some random number. And then Hossein goes off to London. I'm here in San Francisco, and if I want to send Hossein a message, I use that secret key to encrypt the message, and then Hossein uses the same secret key to decrypt the message, and anyone in between can't decrypt the message because they don't have the secret key. The problem with that is that Hossein and I have to meet in person and share that secret key. So public key cryptography, also called asymmetric cryptography, whereas the first one's called symmetric. But public key cryptography, the idea there is that there's two different keys. There's a private key and a public key. And so I would have a public key and a private key, and then Hossein would have his own public key and his own private key. The private key is, both of them look like random numbers, but the private key I keep private on my computer, secured, or on some trusted hardware. It's encrypted. I don't share that with anyone, but I share my public key. And similarly, Hossein, when he shares his public key with me over the internet, anyone can see the public key, but he keeps his private key private. And when you have a message, the way that works is I have a message I want to send to Hossein. I look up Hossein's public key, and I use his public key to encrypt the message. I send it to Hossein, and then Hossein uses his private key to decrypt it. So there's a different key for encrypting than from decrypting. Two separate keys. Yeah, so there's in public key cryptography, there's two separate keys. Now, cryptocurrencies. The idea here is all cryptocurrencies use public key cryptography to create transactions. And generally the way it works is thinking through this, suppose you already have funds in a cryptocurrency, and you want to send those funds to some other. So let's say I have my Bitcoin, and I'm trying to send Bitcoin to Hossein. So the idea there is I have a private key and a public key, and I'm simplifying here, but what I can do is I can create a transaction where I use Hossein's public key. So I know Hossein's public key. You can think of it as his wallet. The public key is being the addresses of the wallet. But I can create a transaction that says only someone that has a corresponding private key to this public key can retrieve these funds. So cryptocurrencies are, you can think of them as bearer assets, where if you hold the private keys belonging to a wallet, then the network considers that the coins associated with that private key to be your own. So it's not like a registered asset, like in PayPal, for example. Since PayPal is in my mind right now, and it's a pretty common payment platform, those on the internet that's customer facing before Bitcoin. In PayPal, you would have some amount of funds associated with your account registered with PayPal. And to gain access to those funds, you would go to the PayPal website, you would have an account, it would go through some kind of authentication, username and password, maybe there's some multi-factor authentication, and that would identify you as being the owner of the account. And then you would specify some other user who belongs to PayPal. You specify their email address, let's say, or their PayPal account name, username, and you would send funds. And PayPal is a central entity, one organization that has basically a list of people and the amount of funds. And when you go through so it's registered with PayPal. And so you go through an onboarding process where you would provide your driver's license or some kind of identity information that would prove that you are the person you say you are. You would connect your credit card or some other kind of bank account with that, and then PayPal would be responsible for authenticating individuals to make sure you are the person you say you are, and keeping track of the funds and having their own centralized ledger, and then updating the ledgers when there's a payment that's made, and then extracting the fee for those payments. So in cryptocurrencies, there's no central group like PayPal. There's no central company organization that has this ledger that they manage, and where this organization is responsible for identifying or authenticating people. Like authenticating meaning like being able to trace that this real world person belongs to this account. So in cryptocurrencies, there's no central group that does that. Typically, you would have in cryptocurrencies, there's a few different types, and we'll go into the different types of like Ripple versus Bitcoin. But typically, you can run, anyone can download the software, run their own node, and participate in the network. and their personal computer would participate in validating these transactions. And there's no mapping between real-world identities to these to the Bitcoin wallet or to wallets or public keys. So you can think of a wallet as just an account that's identified by a public key. Some way to think about it. So so the two key properties for cryptocurrencies that are different from traditional like PayPal or just digital electronic payments are one, that they're decentralized. There's no central entity that manages and maintains the network and is responsible for authenticating people. There's none of that. It's decentralized, meaning you have multiple organizations running nodes. Sometimes you don't even know who the organizations are, which is important for decentralization. And like there's kind of a famous saying where if you can sue it, then it's not decentralized. And then the second thing being the cryptography, the public key cryptography. So when you create a transaction, you are spending coins that have previously been sent to you, and you're using your private key to spend those coins, and then you're sending them to someone else that has a different corresponding public key. So everyone in these networks has a private key and a public key, and they're using those to decrypt their funds and create new transactions that send funds to other people in the network. Now, you do have, like in Bitcoin, you do have companies like Coinbase that will manage people's wallets, users' wallets on behalf of the user. In which case, it's more kind of like it becomes more similar to how PayPal works in that case. So Coinbase, you go through identification process. Coinbase knows who you are when you onboard, and they just have their own central ledger keeping track of balances within Coinbase, and then you would create transactions if it was Bitcoin or Litecoin or what have you when you're moving in and out of Coinbase. And people do that for convenience, but in that case, Coinbase has control of your public and private keys on your behalf and is creating those transactions for you on your behalf. But the important thing is cryptocurrencies, they are bearer assets, meaning if you hold the private keys, then they're yours. So if I gave my private key to Hossein could just create a transaction and spend all my coins. And there's no prevention of that or recourse. There's no central entity that's responsible for keeping track of, which individual real world identity is responsible for the coins, like there is in PayPal. It's anyone who has a private key, it's their coins, which is pretty different than normal payments and normal money. It's more like, it's more like paper money or gold or something like that, in the sense that if you own it, then it's sort of yours, and it's not registered somewhere, and then you don't have to go through this like third-party service to spend or send coins. Another thing that's slightly different about cryptocurrencies is it's sort of a push-based model for payments. So it's not like you can like approve or approve a payment that's being sent to you. So I can just send coins to, if I have my private key and I have my wallet which has some coins in it, I can just send it to Hossein, and it's not like he can reject that transaction or say no. It's sort of a push thing where I create the transaction and now the coins belong to Hossein, whether he wants them or not, which is, it can also be different than other payment systems where you can reject transactions and you can, not approve certain transactions. Typically, cryptocurrencies have people talk about finality, like there's no, because of the security is backed by cryptography, and the way it's designed, it's the transactions once they in a blockchain-based cryptocurrency, once they're in a block confirmed, after a certain number of confirmations, just a certain amount of time, the transactions are final. So it's very difficult to reverse a transaction. So when you think of like a credit card payment, typically you would be able to do a chargeback or talk to the credit card company and say, okay, this transaction was fraud. Let's reverse it and give you back the funds. There's none of that in the land of cryptocurrencies. Once you've created a transaction and the network has placed that in a block, for all intents and purposes for this discussion, it's final. There's no way to get your coins back. There's no central entity you can go to. There's no credit card company you can go to sort this out if it's fraud, let's say. Anyway, that's bigger picture cryptocurrencies. Really, there's some challenges when developing a cryptocurrency, and Bitcoin was the first cryptocurrency to solve those problems. So one of them, at the end of the day, what gives a cryptocurrency value? Well, it's, at the end of the day, it's just, you can think of it as just account balances, but the value comes from, both the network effects, like how easy is it to use the cryptocurrency to create transactions, security, meaning am I confident that if I create a transaction and send coins to someone else, they show up there. But it's really, people believe in, they trust in the network and they find it useful, and that's what gives it, that's what gives it the value. And but at the end of the day, you're updating the account balances in a network that's being maintained by a number of nodes that keep track of that. So there's no, concrete link between, like in cryptocurrencies, there's no company that's like backing the value of the cryptocurrency. So it's not like, there's some company that's going to control the exchange rate or something between the cryptocurrency and US dollars or anything like that. So because cryptocurrencies, it's a bearer asset, it's based on public key cryptography. Typically the identities of the individuals are not known. It's hard to identify people, where the payments are coming from and who they're going to. And anyone can participate in the network, generally speaking. So all the cryptocurrencies we'll talk about today, like anyone can create a public and private key and receive and send funds. So going back to the list here. So so crypto as a store of value. It has value because people find it useful to be able to, they believe in the network and they trust that the network is going to process their transactions and that their transactions are going to be final, that the network can't be hacked. But at the end of the day, people find it useful. Now developing, getting the incentive structure right was a huge challenge. And I mentioned the cypherpunk movement who were trying to develop, cryptocurrencies before they were sort of called cryptocurrencies. And you see some initial ideas before Bitcoin came on the scenes. But some of the big challenges were how do you prevent spam? And suppose you have some cryptocurrency, and you're just starting a network, running decentralized technologies. It costs money. It costs. Forget the mining for a second. Suppose there was no mining. We briefly talked about mining in the previous session. How do you? It takes resources to run these servers, run the software. Just the energy alone costs something. And so, how do you prevent people from overloading the network and prevent spam? Meaning spam emails. And that's where some of the initial ideas came in, and that's eventually the ideas that led up to proof of work came out of sort of spam filters and prevention of spam by and the idea, but most of these cryptocurrencies, the way that there's a transaction fee. So your transaction fee would either go to, in the case of Bitcoin, it would go to miners who are responsible for maintaining the network. And in some of the other cryptocurrencies, the transaction fee doesn't go to anyone. It just gets what they call burned. It gets destroyed. But because there's a transaction fee, it's a mechanism to reduce spam, because the spammer then has to pay money to create transactions. And it's not, and running a network and just running software has some, has costs associated with it. Now, Bitcoin, we briefly talked about it last time, but in the Bitcoin network, there's also a correlation. I mean, it's not just like miners have to spend not just the amount of money to run their servers to process transactions, but they have to spend a huge amount of money to mine to find these blocks. And so there's a relationship between sort of the cost, the dollars to secure the network, or the cost in some kind of in energy to secure the network, and the price of Bitcoin. Meaning, it wouldn't make sense to spend millions of dollars of mining Bitcoin if it has very little value. So okay, moving on here. We talked about Bitcoin extensively in the previous session, so I think we had the gist of Bitcoin. So forks. The idea here, so first it was Bitcoin. The first sort of, or the largest, I guess, mainstream fork of Bitcoin. Well, let me explain what a fork is first. So in the previous session, we talked about consensus. So in the Bitcoin network, you download software, you're running the Bitcoin service, and its nodes are coming to consensus or agreement on the latest block and the entire history of the blockchain, like all the time. And so if a transaction shows up or a block shows up that doesn't meet the agreed upon rules that the software says, then the software will reject the transaction or reject the block. So if the transaction is not in a block yet and is just propagated through the network to be placed in a block, the transaction doesn't meet certain rules, like things like, does the sender have the necessary funds? Like, do they have the right private key to unlock the funds? Those types of things. Like, if the transaction doesn't meet those validation rules, then it's just ignored and dropped. It's not propagated to the rest of the network. And similarly with blocks. So a fork is a change in the consensus rules. So that means you have the network, it's up and running. You got a bunch of nodes participating in it. People are creating payments. They're using their private keys to create transactions and send to other people. And the developers and the community decides they need to change the network for some reason. So it could be a bug, like there might be, so like the initial versions of Bitcoin had what are called integer overflow bugs. That you can think of, it's just bugs that would let you do things like have millions of Bitcoin, like or exceed the maximum number, 21 million Bitcoin. So the original Bitcoin had a cap on the number of Bitcoin that would ever be issued in the network. And there were bugs that let you go beyond that cap. And so the developers would get together and say, we need to change the software. We need to fix this bug. But it's a decentralized system. That's difficult. It's not like PayPal where, you just get your dev team together and your operations team and you do a release. No, because it's decentralized. You don't even know who's running the software. It's all over the world. How do you get everyone to upgrade the software? So there are different types of forks, but there are things called hard forks and soft forks. Soft forks, but they both relate to consensus you're changing the rules of consensus. So you're saying that transactions that were previously rejected are now going to be allowed, right? Or you're going the other way and saying that transactions that were previously allowed are now going to be rejected. But you're changing the rules of the game. You have to change the software so that you're changing the system. So anyway, there are two different types. A fork just means changing the consensus rule. You're changing the software. There are two different types of changes. There are changes that are backwards compatible, where only some of the network needs to update, and the network will continue to run. You don't need everyone to upgrade. Kind of like, your iPhone. All the recent releases over the past year and a half are backwards compatible, meaning I can still use my iCloud even if I'm on an older version of iOS. And then there are backwards incompatible changes, and that requires you to download the new software in order to participate. And so hard forks are consensus changes to the rules that are backwards incompatible. And those are very controversial in general. You don't want to do that. If everything's sort of humming along and kind of working, unless it's really, really bad, the whole network's just going to stop, you generally don't want to have a backwards incompatible change, because then everyone would have to download the new software. You'd have to get everyone to go over to the Bitcoin website and download it. Anyway, it's an operations nightmare because it's decentralized. So it becomes like a political thing to get people to update their software. You have to convince people they need to make this change. Soft forks, they're backwards compatible, so you only need a few people to make the change, and you can start seeing the benefits, and it interopts with the old pre-soft fork version of the software. So anyway, those are forks. So Bitcoin, probably the most famous hard fork. There's been soft forks, and you don't really hear about them because you don't have to download new software. You don't really have to think about it too hard. But the Bitcoin developers, Bitcoin core developers, periodically do soft forks to improve things like the security of the network. And anyway, it's a longer discussion, but they happen frequently. Hard forks in the past, in the original versions of like the first few years of Bitcoin, there were several hard forks, and those were like if we don't make this change, the whole Bitcoin network is just going to stop and not work. And so they weren't controversial. Everyone sort of understood, okay, just update it. It's got this problem, this integer overflow problem I mentioned. You could kind of create new coins. But probably the most interesting case is Bitcoin Cash, which is a controversial hard fork. So Bitcoin Cash is it's a separate cryptocurrency. It was a hard fork, a controversial hard fork from regular Bitcoin. And what that means is up until maybe a year ago, about a year ago, January 2017, the blockchain, so both crypto, so you have Bitcoin and Bitcoin Cash, two separate Bitcoin, I'll just call it Bcash, two separate cryptocurrencies. Up until January 2017, the blockchain, meaning all the transactions, all the blocks, all the amounts of money that everyone has, is exactly the same on both networks. So if I have a Bitcoin private key and public key that and I created a transaction 2 years ago, that same transaction is going to show up in Bitcoin Cash. And so the blockchain is exactly the same up until January of last year. But then after that, they made a group of people made their own version of Bitcoin software with different consensus rules. It was a hard fork, so they changed the rules of what is a valid in this case, it wasn't a valid transaction, but what is a valid block? So they were interested in making what's called, a block is a bundle of transactions, and there's a limit to how many transactions you can put in a block, right? And so it's just a limit that's coded in the software, and that limit would do things like ultimately it sets the amount of transaction throughput you can have in your network. So if you can have larger blocks, you can fit more transactions in the block, and let's say you're just validating them at the same rate. In Bitcoin, it's every 10 minutes. Then you could have higher transaction throughput. And so the Bitcoin Cash community said, look, like there's all these people that are into Bitcoin, like this is going to have to be electronic peer-to-peer payments, like for the entire world. We need higher transaction throughput. Like the 7 transactions per second of Bitcoin is not enough for our Visa scale. So we want to increase the block size. And that's a change that is a hard fork. It changes the consensus rules. Previously, blocks that were greater than a megabyte were rejected as being invalid blocks. And in their version of the software, blocks that are can be bigger than a megabyte. They can be different sizes, like 4 megabytes or even beyond that. So they created this version of the software, Bcash, and it's a fork. It's like Bitcoin, and all the transactions and blocks are the same up until a certain date. But then afterward, there's new transactions that are created on the Bitcoin on the Bcash network that don't show up in the Bitcoin network, and vice versa. And so what that meant was, on that date, if you had a public and private key, and you had a wallet on the Bitcoin network, let's say you had 10 Bitcoin, then on January 2nd, Bcash launches. People are downloading, instead of running Bitcoin, they're running Bcash. That means you now have 10 Bcash. So you have 10 Bitcoin and you have 10 Bcash. So Bcash, in a way, is sort of like paying you to participate in the Bcash network. That's also called like this idea of just like handing out cryptocurrency to get people to participate is also called an airdrop. You may have heard that phrase, but Bitcoin Cash Network gives you coins if you already had a wallet in the Bitcoin network, and so you can just participate in Bcash. But the two networks are incompatible. You can't send Bitcoin Cash coins to a Bitcoin wallet. The other way around. Like you can't send Bitcoins to a Bitcoin Cash wallet, for example. And so the networks are forked. They're two different blockchains, but they're the same up into a certain point, up into a certain block. Now, so that's a fork, Bitcoin Cash. So Ethereum showed up, and it's a whole different network. So it wasn't based on, it's not like a copy of Bitcoin, but with some changes. It's an entirely different network. The way they process transactions is different. It has this the smart contracts, which we'll do another session on. But you can think of it as just a whole totally different network where in the beginning, some of the original founders of Ethereum have coins issued to themselves, kind of like in Bitcoin. Satoshi has a bunch of Bitcoin issued to himself, but it's a whole different blockchain. So you create a new Ethereum wallet and public and private keys, and you can send Ether in the same way like in Bitcoin you can send Bitcoin, and but Ethereum was designed to solve different problems, and we should have a whole other session on that in terms of smart contracts, because that's really the key difference between Bitcoin and Ethereum. Is that Ethereum was designed so that you could run not just do payments and send Ether to and from two different people, but you can actually run other computer programs on the Ethereum network and build other things. This is where you hear tokens and ICOs, and we can talk about that in another session. But Ethereum, totally different blockchain, totally different cryptocurrency, Ether. But it's a decentralized network, similar to Bitcoin, not the same decentralized properties, but anyone can create a wallet. They can send Ether to each other, and the network is powered by Ether. You pay you pay a transaction fee that goes to miners in Ether, and to run your smart contract, you pay Ether to run to do that as well. Now, Litecoin is it's considered you can think of it as it's like Bitcoin. So it came out in like 2011, I think, like a few years after Bitcoin. The Bitcoin paper came out and the code was open source. And so what people were concerned about with the Bitcoin network was this miner sort of centralization. So because of how the mining works and the algorithms that are used, if you're going to become if you have a lot of resources and you're building a business around mining, you're going to develop the most efficient way to compute these hashes and to mine these blocks that cost the least amount of energy, that lets you compute the most hashes. Because the whole, as we talked about in the earlier session, the whole way mining works is you're generating these random numbers and you're hashing these blocks and you're trying to find a number that has a certain property in order for the block to be valid. And it costs a amount of energy to do that. And so miners, they're incentivized to reduce their costs and to come up to find to be a profitable business, to find cheap money and cheap ways of generating these hashes. And so Bitcoin chose certain algorithms to do that hashing, and people were concerned about that because those algorithms could be implemented in custom specialized hardware. So you hear things like, so when Bitcoin started originally, people would just do it on their personal computer, and that was great because it was the mining was decentralized. It meant that Hussein could download it on his laptop, I could download it on mine, and a lot of people could early on just mine on their regular computers and get some Bitcoin for doing that. We're all sort of on equal footing. Maybe someone has 10 computers or whatever, that's a small data center, but their mining ability wasn't huge orders of magnitude greater than an average person with their laptop. And so people like that property because it was decentralized. It meant that a lot of people could participate around the world in mining. Well, with the hashing algorithm that Bitcoin chose, it was amenable to developing custom specialized hardware to speed that up. So first it went to GPUs, which isn't custom hardware, but you could run the algorithm on a GPU and it would be a lot faster than on a CPU. So now people with GPUs had sort of an edge. They could mine 10,000 more hashes per second than someone on a CPU, or more like 1,000. But so an order of about 1,000. And then people went to more specialized things like FPGAs, which are reprogrammable pieces of hardware. But it's like a hardware, so it's not a CPU, it's not a GPU, it's a more specialized piece of hardware that you can configure. And in this case, you can configure it to mine Bitcoin and compute hashes in Bitcoin. And so now you're looking at speeds of a few hundred X on, or 10 to 100X on the GPUs, and FPGAs are even more inaccessible to your average person. I can go buy a GPU, but if I'm going to go out and buy an FPGA, it's a lot more expensive, it's more difficult, it's more specialized, it's harder to set up and configure, so it becomes more specialized. And then ultimately, people went to ASIC, which is just a complete custom hardware chip that's not reprogrammable. It's just completely specialized to mining, to computing these hashes for Bitcoin. And that's what everyone mines Bitcoin with. All these miners mine Bitcoin with today on these special ASIC chips. Now, Litecoin, they were concerned about that. They didn't like the idea of mining being centralized to only a few organizations that could afford to do ASIC chips. And so early on they saw like, okay, these algorithms that can be parallelized and implemented in hardware and have huge performance benefits for doing that. So they decided to come up with different hashing algorithms that were more resistant to specialized hardware, so that they could try to keep the network decentralized, the mining in the network decentralized. And so they used a hashing algorithm called scrypt, which was designed to be more resistant to specialized hardware and be less parallelizable and amenable to specialized hardware with huge performance gains. You still get some performance gains, but not like in Bitcoin where it's 100x on your ASIC than on your CPU. It's more like with ideally you're looking at like 1,000 to 10,000. So it's it's a different set of algorithms as part of the mining that to try to make it more difficult to have a competitive edge with customized hardware. And it's a whole new blockchain, so it's not a fork. It's just a whole new blockchain that has a different consensus algorithm, a different hashing that uses scrypt to be more resistant to specialized mining, and then they made some other adjustments, like instead of the network trying to mine blocks every 10 minutes, like in the Bitcoin network, it's every like few minutes, like 2.5 to 5 minutes. Okay, Zcash. So Zcash, they did not like so in Bitcoin, I mentioned these public and private keys. So you have a blockchain, so you have all these transactions. Anyone can download this list of transactions, and they can see a transaction between these two public keys, and they can see the transaction amount. So you don't know who owns who owns the corresponding private key. You don't know that. There's no central registry or anything like that says this public key belongs to this real world person. So you don't know. So people call this pseudo-anonymous. I mean, it's not completely anonymous. You can see transactions, and you can see between public keys and the values, but you don't know necessarily who owns those private keys. Now Zcash, they didn't like the fact that you could see the transaction amounts. So they wanted to add more anonymity to protect people's transactions. And the way they did that is they took Bitcoin, and so they didn't fork. It wasn't like Bitcoin Cash where it shares the same blockchain. It's a whole new blockchain, but they started off with Bitcoin, the Bitcoin code base, and the same architecture as Bitcoin. But they added, by using some really cutting-edge crypto called zero-knowledge proofs, which we'll talk about later, they added a way for you to take your coins and create transactions that are private, that don't leak the identities of the people involved in the transaction or the transaction amounts. So that's all hidden. So it's like Bitcoin, but with more privacy guarantees. And it uses this crypto called zero-knowledge proofs, which we can talk about in a different session. But outside of that, it's very similar, if not identical, to Bitcoin. But you can take your coins and create these new types of transactions that preserve confidentiality. There's a trusted setup involved, meaning you have to trust. There was a group of developers that launched the Zcash network, and as part of creating that network, you have to trust that they destroyed certain keys. So there's some trust you have to give in the initial creators of the network in order to maintain confidentiality. But yeah, you can think of it as Bitcoin, but confidential. Okay, that was Zcash. Now, Ripple. So Ripple, it's a cryptocurrency. So it, unlike Bitcoin, where anyone can, maybe we should pause. Maybe we should pause here, and so we have a few minutes for questions, and then we can dive into Ripple either in another session or we can go over.
Okay, thanks, Sam. I have a few questions to different points within the session. So let's start at the beginning when we talked about the keys. So you mentioned there's always a private and a public key, and you would kind of send it with the public key, but then the person who wants to open the transaction needs a private key. So I was wondering, does each public and private key kind of fit together? Like, so does the private key know, or does the public key know I fit to this private key? Does that make sense?
That's right. Yeah, you can think of it that way. That's right. Yep.
Okay, cool. And then you also mentioned Coinbase in between, and you said that they would have your keys actually. So I was wondering, is Coinbase an exchange, or is it like a fund manager or something?
They call themselves an exchange, but what they do is they create wallets on your behalf. And so they create a public key and a private key, and then they store that on their servers. So you don't have access to the private key that Coinbase owns.
Okay.
It's just their wallet and their private key. And then you log into Coinbase like you would with PayPal, and you can instruct Coinbase, hey, send these coins to this other person, and you're trusting them to do that, to use that private key to do that. But with Coinbase, now there was this huge thing, there's this other exchange called Mt. Gox, which was like Coinbase at the time, and they got hacked, and it was poorly run, and a lot of people lost millions of dollars in their Bitcoin because they didn't have control over the private keys. It wasn't really theirs. They were trusting this exchange to hold on to the keys for them, and they didn't do a very good job protecting their users' keys. So with Coinbase, you trust Coinbase, to do that. Now, in terms of the exchange piece, it's not just that Coinbase holds on to your keys. They also let you buy Bitcoin with dollars. So kind of like you would register a bank account or a credit card number after you identify yourself, provide your driver's license, etc. And you can purchase Bitcoin using your dollars, and they'll add it into your account. But if you want to send it to a private key that you own, then you have to create a transaction, or you have to trust Coinbase to create a transaction and send it to your own public key where you manage the private key yourself.
Okay, I understand. And then later on, we talked about the forks, and I understood the main part. The only thing I was wondering is, for example, in the example of Bitcoin and Bitcoin Cash, who actually came up with the fork? So who was saying, oh, we need to do it that way, and therefore please all follow me and become Bitcoin Cash instead of Bitcoin, for example? Is that the development team of Bitcoin that suddenly kind of has a dispute, and two people want that and the other two people want the other thing?
Yeah, it was really controversial and very vicious. And so there's a group of people called, it's not a company, it's just a group of individuals called Bitcoin Core, and they have access to, so there's a software repository system online, called GitHub, where it's, it hosts most of the open source software in the world. And Bitcoin, the version of the Bitcoin software that most everyone runs is called Bitcoin D, and there's a group of developers that have access to that code and can make changes to the code on GitHub. And that group of developers is called Bitcoin Core. And it's not a company, it's just a bunch of random people from different companies that have access and can make changes to Bitcoin, to that version of the Bitcoin software. There was a separate group, so the Bitcoin core developers did not want to make this change. They were very against it. And it's probably a much longer discussion of why you would want to keep the block sizes smaller, but ultimately by having larger block sizes, you're going to have less. They thought it was unnecessary. You could do other changes to improve the throughput without having to change the block size. And also changing the block size comes with a cost. And so they were staunchly against this. But there were a few sort of Bitcoin celebrities, like they weren't developers, but they were people who were early on in Bitcoin that bought a lot of Bitcoin early on and made a lot of money, and they were very vocal on YouTube and these blog posts. And I should mention there were some old school developers, two of them, that were previously involved in the Bitcoin core group but had since left, that were in favor of this change, but they weren't actively developing the new software. It was mainly led by these sort of YouTube personalities and celebrities that went out and found another developer to pay to do their version of this Bitcoin Cash thing.
Okay, but that developer that they paid, did he have to be part of this core group?
No, so they just created created another Bitcoin software and created another project on GitHub.
Okay, kind of copied everything besides the change.
Yeah, to make the change, and then they went out and then evangelized to try to convince the community to download this other software.
Okay.
Which, you can imagine it's pretty difficult, right?
Yeah.
But it was very controversial and very ugly. I mean, a lot of people who were into Bitcoin got turned off and walked away from it because of these like very public and ugly debates.
Yeah. Okay. Cool. No, I understand that. I think that's it from my side on questions.
Okay, Sam, do you have anything further?
We could briefly talk about Ripple if we have a few minutes.
Okay.
Yeah. So Ripple, so there is a company called Ripple that invented the Ripple protocol. The company, so the Ripple protocol has a cryptocurrency called XRP. Ripple, the company, owns a huge percentage of XRP because they invented the separate cryptocurrency, and it is different from Bitcoin and Ethereum in the sense that the people who perform there's no mining. There's validation of blocks. There's transactions. You have public and private keys. I can create my own Ripple account, my own Ripple wallet. But it's different in the sense that the servers and the nodes that validate the transactions and create the blocks are not performing mining. They are known identities. They have they are known real world identities. So it's like when you run the Ripple software, you specify the other nodes that you trust to validate the transactions for you. And there's sort of a common set that the Ripple network has agreed upon, and everyone knows who owns those nodes, and they trust that the people who own those nodes are going to do a good job and validate their transactions properly. There's some safeguards to make sure that if someone misbehaves, they can detect that, and only a certain percentage, it can tolerate up to a certain percentage of nodes misbehaving or trying to double spend, things like that. But the block, there's no mining. The blocks, you're trusting that a certain percentage of the nodes are behaving well, that are validating the transactions, are following the rules, and those validators are they are known. They're known companies, and when you run the Ripple software, you specify who you want to trust, like which of these companies you want to trust to validate your transactions, or you just download previous lists, like the default list that comes with the software, which has, the Ripple, the company, their validators on that list to validate your transactions for you. So it's decentralized in the sense that you don't have to trust just Ripple, the company. There's other companies and universities. I think MIT might have one. You can trust them to run their nodes, and you can configure your software to do that. But it's more centralized than Bitcoin because there is this company that's sort of, responsible for maintaining the software and evangelizing the software and getting new organizations on board, and they own most of or a huge percentage of the XRP coin. When you create transactions, there's a transaction fee. The fee does not go to the validators. It gets burned. So it just gets destroyed, and that is to fight spam. Like we talked about spam earlier on. Like there needs to be some cost to create a transaction because at a minimum there's costs in processing the transaction. So that's really high level overview, but you can think of it as a cryptocurrency. Yes, it's decentralized. Yes. But you're looking at only a handful of validators. I think there's I'm pretty sure it's less than 100 validators, and their identities are known up front. They're all registered, and people trust them because they trust those companies. And there's one company, Ripple, that is really kind of shepherding this whole network and developing the software.
Okay.
Any questions about that?
No, I think I understood. So the main difference is that, first of all, it is kind of decentralized, but you do have entities that are known rather than just random people, if you call it like that. And secondly, you pay instead of for the transaction instead of you getting money for it, right? But this fee that you pay is then burned, as you said.
Yeah, it doesn't go to Ripple, the organization. Yeah. It doesn't go to the validators or anything like that. It just gets destroyed. So the incentive for being a validator is really that you want to promote, maybe you own a lot of Ripple and you want to promote the network and you want a healthy network, but you're not getting paid to run your validator.
Yeah.
Very different than in Bitcoin. In Bitcoin, people mine because they want to make money. I mean, it costs a lot of money to do it. It's a lot of work, and they want to get those transaction fees. And there's a reward when you mine a block. The network rewards the miners with a block reward as well. So the incentives are very different. Yeah. And in Bitcoin, you don't know who the miners are. Their identities are hidden and anonymous or pseudo-anonymized. Whereas, in practice, people kind of have a general sense of who the miners are. But in Ripple, it's very clear. To become a validator, you register and you let everyone know, hey, I'm a Ripple validator. This is my address. I will validate your transactions, and people will generally trust you if you're a reputable company and configure their software to use you as a validator.
Okay. So just one tiny question with regards to that. So I can just decide if I'm an organization that I want to become a validator, or do I need to apply or something to the Ripple company? You would probably want the Ripple company to be on your side. Mm-hmm. So but you don't have to. Okay. So you would, because everyone involved in Ripple trusts the Ripple company, you would probably want the Ripple company to promote you and put you on their website, but you don't have to. Okay, got it.
Yeah.
Okay, great. I think that's it from my side.
All right. Thank you so much, Sam. That was very productive. And next time we will go on to the next topic at hand.